Hello! In this video, we're going to learn how to find the epicenter of an earthquake. In order to do this, you need three things. The first one is that you need a map, just like this. You also need the procedure that all the steps that lists all the steps that you need to follow. And you also need the seismic station data sheet with the seismogram and the information that you will need based on the different seismic stations that you are being reported. Coming back to the map, before we actually begin with the procedure, notice that your map shows the different places where you can have an epicenter. The earthquake was felt somewhere right here, and notice that we have information for different stations, including station A, we also have station B, and we also have station C in this map. Notice that eventually every station will report a circle. The circle is the indication of where in this circle you can have the epicenter for that specific earthquake. Every station will show the circle as possibilities for the epicenter. As you can imagine, this gives a lot of possibilities and a lot of options. So that's why the more stations that we have, the better. So let's actually look at the procedure and let's focus on step number one. Step number one, it actually says to observe the circle for seismic station A1 distance to the epicenter that has been drawn to you. So when you look at the map, that's exactly what we just did. We just focused and we saw that there's this circle for there. Now, step number two, it says to write the code number for seismic station B1 from the seismogram on page 2 and put it in the map. When you look at the seismic station B1 from the seismogram, remember this is your seismogram, notice that it says the code number is 111704. So that's what we need to do, and we need to record that on the top of our maps. Notice that right here it says the code number. So this is where we would put, in this case, for this example, 111704. And that is the code number that we just recorded from the seismogram data sheets that we just received at this moment. So notice that we just put 111704 and we copy that from the seismic station data sheet. So we're done with step number one and we're step number two. Now let's go to step number three, where you have to write the distance from seismic station B1 to the epicenter from the seismogram on page 2 to the map. So we're back here in the seismogram and notice that we're writing down now the distance. Notice on the top it says distance from seismic station B1 to the epicenter is 3,600 kilometers. So we're actually going to write this number right here. Notice that under the code number, it says distance from seismic station B1 to the epicenter, and this would be 3,600 kilometers. So we are just finished with step number three. We are now going to move to step number four. It says, with the given distance from seismic station B1, use a compass to draw a circle around the station to represent the distance from B1 to the epicenter by using the map scale under the map. So notice that now it's time for us to use a compass. You need a compass in order to do this here. Notice that we have distinguished and that it's going to, the distance from seismic station B1 to the epicenter was actually 3,600. At the bottom of the map, you should be looking at the scale. So when you look at the scale right here at the bottom, you should be able to see that it has in kilometers, the distance, it goes from 0 all the way to 8,000. Well, we want to go to 3,600 because that is the distance from seismic station B1 to the epicenter. So by using our compass, notice that the compass has two sides, the pointy part and it also has the pencil part. By putting the pointy part at the beginning at 0, we're going to start right there and we're going to extend it all the way to 3,600. The thing is that if you want to make sure that you are doing this correct, and I'm going to zoom in so you can see this much better, notice that 3,000 begins right here. And we know that 4,000 begins right here in this location. If we want to, let's say we split it in half. So this would be like 3,500, but we want to go to 3,600. So it looks like it's going to be probably somewhere right here. So with that in mind, we're going to put our compass and we're going to start, and again, we're going to put the pointy part at 0 and the pencil on 3,600 so that it looks something like this. Notice that this is the size that we represent 3,600. And this goes back to the distance for seismic station B1, meaning that we should be doing this for station B1, or station B. We know that station B is right here in this part of the map. So now we are going to be using our compass without changing it, and we are going to be putting the pointy part on the B. As we do this, notice that it kind of goes off the map, but we want to just do the circle in the map because we really don't need the compass circle to go around. As we go around, we start to make this circle, and notice that it starts to record because of our compass, the circle, as you can see right here. Great. So now we have not only a circle for A, but we also have station B circle, which happens to be right here. So now we have another circle, which means that station B says that the earthquake epicenter could be somewhere around this circle. Okay, that's progress, but still, it's not exactly telling us where is that epicenter. And we're not finished, so let's keep going. We did steps 1, 2, 3, 4, and now it's time for us to do step number 5, where it says for seismic station C1, so notice that we're now focusing on seismic station C. It says to use the seismogram on page 2 to determine the time difference between the arrival of the P wave and the arrival of the S wave. So now we're using the seismogram, and you have to record the difference in distance on the top of the map. So now we're looking at the seismogram for station C, and we need to, again, coming back, we need to use this to determine the time difference between the arrival of the P wave and the S wave. So we can see the P wave actually began right here. That's where it says it began. And we can see that the S wave says that it began right here. Well, we want to know what is the time difference. By the way, P wave began at 3 minutes, S wave began at, it looks like this is 6 minutes and 50 seconds. And I want to remind you that there are 60 seconds in every minute. So that means from 6 to 7, that would be 60 seconds. So that's like 20 seconds, 40 seconds, 60 seconds. But notice that S wave is like in the middle. So that would be like 20, 40, 50 seconds. How did I determine that? Because if this is 40 seconds and this is 60 seconds, even if it's in the middle, that would be 50 seconds. So overall, the distance from the P wave to the S wave is 1 minute, 2 minutes, 3 minutes, 3 minutes and 50 seconds. So now that we have this, coming back to the instructions, it says to record the time on top of the map. So when we're back here with the map, notice that at the top now it says for station C, it says that the time difference between P wave and the S wave should be 3 minutes and 50 seconds. And that is exactly the number that we just came up because of our definition. So we're basically done with this step number 5. We are now going to move to step number 6. It says using the time difference from step 5, so that means the 3 minutes and 50 seconds, now we have to use the P and the S wave travel time graph in your best friend, page 11, to determine the distance from seismic station C to the epicenter. And you have to record the distance at the top of the map. Okay, so now we have to use the best friend, page 11, which looks like something like this. Notice that on page 11, you have the travel time on the y-axis and on the epicenter distance on the x-axis. We have that here, and notice that it's asking you to use that graph to determine the distance. So we need to find the distance But we have the time because we determined that the time was 3 minutes and 50 seconds. So what we need to do is we need to get another piece of paper. So you can use a scratch paper or you can use the back of the map. So in this case, I'm just going to show you with a piece of paper that I have here. And let's actually zoom closer so we can see this much better. As we go through here, notice that we are looking at the paper has to be aligned. The piece of paper has to be aligned next to the y-axis, something like this. And notice that we're going to make one line that shows where it begins. So this is connected, aligned with the 0. And then we want to go 3 minutes and 50 seconds because that is a time difference that we received. So this is 1 minute, 2 minutes, 3 minutes. You can kind of take this off if you want to see this, but I know that 3 minutes and 50 seconds looks like it's going to be right here. So that is 3 minutes and 50 seconds. So I just wrote this for reference for myself. And I know that from here to here, that's 3 minutes and 50 seconds. Now, I have to bring this across to see where this line will touch the line on the top and then how the bottom line will touch the line at the bottom. So until they touch, obviously here, if I put it somewhere right there, that's too small for those lines. So you have to bring it until they actually can touch, both of them. So although I'm getting closer, I believe that the answer would look something like right here. Notice how the line on the top is actually touching the line on the next to it, and then the line at the bottom is actually touching the line next to it. Well, I'm not finished because I need to find the distance. So remember the distance is at the bottom. At this moment, you bring this to the bottom. So you just keep going until you hit here. And notice that exactly it's pointing and it's looking at it's right here. That part right there. This way I can just take this off and I can determine this is the place where the distance. Notice that this is 2,000, 200, 400, 600. So I can believe that the distance for this station is 2,600. Nice. So notice that that's exactly what I did. And it says to record the distance at the top of the map. So when you go back to the map right here, notice that you look at the top of the map and notice it says the distance from the seismic station. And this is where I would write that 2,600, which is a number that we just found from your best friend. Okay, so let's come back here to the instructions. It looks like we are finished with steps 1, 2, 3, 4, 5, 6. And now we're in step 7, where you need to use the compass to draw a circle on the map to represent the distance from seismic station C1. So we are exactly at that point where we need to use the compass again to find the distance for seismic station C1 by using the map scale at the bottom. So remember that at the bottom, we have this map scale where we are focusing. And we are going to use the compass again to find that or to make that circle that represents the number that we want to use. Before we actually do that, let's remember that we are looking for 2,600 kilometers. So now that we remember that, let's find that here at the bottom in your scale. We know that this is 2,000 right here, and we know that this is 3,000 right here. Now, in the middle, this would be like 2,500, but again, we want 2,600, so it would be somewhere in this location. So then I would take my compass and I would get the compass just like before. I'm putting the pointy part at 0 and the pencil at 2,600, which looks like something and somewhere like that. Without changing the compass, notice that this is for seismic station C. So I gotta find seismic station C, which happens to be right here. And I'm going to put the pointy part on C. Now that I have done that, then I am ready to do my circle. So with that said, I'm going to make my circle like this. And remember, we don't need to go off the map because we are just worrying about doing it on the map. So as we're doing this together, notice that we are getting a circle that looks like this. So now you can see that station C has its circle, which is a little more smaller, that looks something like that. Great. So now we have circles for all of the stations. We got one for A, which was given to you, and then we made one for B, station B, and then we made one for station C, as you can see right there. Let's look at the last or the next step. We are in step 8. It says place an X on the map to show the location of the epicenter. That would be where all of the circles meet. So by looking at the map, we can see that the circles are meeting at one specific place. Yes, at once different points they are touching each other, but where all of the circles meet happens to be this location right here, which means that in this specific location right here, that is where the epicenter happened. So we are going to put an X, meaning that the epicenter happened right here. So in conclusion, notice that stations A said that it was going to happen somewhere along this circle. B said that it was going to happen somewhere around this circle. And C said that it was going to happen somewhere around this circle. And when you put them together, we can see that the earthquake epicenter actually was right here. Hopefully this video was able to help you to find the epicenter of an earthquake. I will see you on the next time.